This is another video in my module on operating with complex numbers, and in this video we're going to focus on how does one divide complex numbers. We've talked about adding and subtracting them as well as multiplying them, but when it comes to dividing them it's a little bit different. So you notice I leave a note here. It says we can find the quotient of two complex numbers, or at least write a complex number in standard form, a plus bi form, that is equivalent to a complex quotient by eliminating the I from the denominator of the quotient. So before I tell you how you do this, I'll give you a rationale why we're doing it in the first place. Recall that I is the square root of the negative 1, or square root of negative 1. And as a byproduct we say I squared is equal to negative 1. But the important one here is this. If I equals the square root of negative 1, anytime you're dealing with a statement like I've got down here that says 5I over 2 minus 3I, when you're dealing with something like this, we do not desire to have an I in the denominator because it is a radical, and of course, in typical terms, if you had something like this, usually we would just rationalize, take the top and the bottom times radical 3 and get like 2 radical 3 over 3. It's not as easy as that when it comes to complex numbers though. So here's the method we're going to use. We're actually going to multiply the top and bottom of our quotient by the conjugate of the denominator, and I say thus producing a purely real monomial divisor. Okay. In our last video we talked about multiplying numbers, and that was something we did. We multiplied two complex conjugates. But what I want to bring up here is this. First of all, when we say we have a complex number a plus bi, we refer to its conjugate as being the exact same values, but one's plus, one minus. And when you multiply these out, what you get is you get a difference of two squares. You get a squared, and then you get minus abi, but then you turn right around and get plus abi for your outer and your inner on your FOIL, and those are canceled. And then you get minus, and then it's b squared I squared. The thing that produces though is this. You get a squared minus b squared I squared. Recognize that I squared is negative 1. So you get really a squared minus b squared times a negative 1, which produces a squared plus b squared. So a couple things we want to recognize about multiplying by conjugates. First of all, you get a purely real result. This is going to be a purely real result. And so if I'm going to take my denominator down here times, say, its conjugate, I'm going to get a real number in my denominator now, which fixes the fact that we have an I in the basement. And also, you want to remember this. Whenever you multiply two complex conjugates, you really just get a squared plus b squared. So let's take a look at a couple of examples. We'll do the long way on letter A here, and then we'll use this a squared plus b squared pattern that we're going to start to memorize on the second one. So the first example says find the following quotients. Well, I recognize we have an I down here. This is highly undesirable. So what we're going to do is this. We're going to take the top and the bottom of this expression times the conjugate of the denominator. So we say we'll take top and bottom. What you do to the top, what you do to the bottom, they have to be the same. But both times 2 plus 3i. So in this case, we'll go ahead and multiply these things out. As far as the top goes on this expression, we say 5i times 2. This is 10i. And then 5i times positive 3i gives us plus 15i's squared. Okay. As far as the bottom goes, we'll multiply all this out. We get 2 times 2, which is 4. Then we get plus 6i. Turn around, we get minus 6i. And then in our last here, we get 9i squared, negative 9i squared. So these two in the middle here, these two I expressions or I terms cancel out. As far as the top goes, we say wherever there's an I squared, that's really just negative 1. So we get this, 10i plus 15 times negative 1, all over now, we say 4 minus 9 times I squared, which itself is a negative 1. And so in this instance, we get this, a negative 15, which is what this is right here. A negative 15 plus 10i, I want to write this in standard form, so I'm going to put it a plus bi form. And then we say on the bottom we get 4 minus a negative 9, okay, or really negative 9 times a negative 1 here gives us a positive 9, so we get 4 plus 9. In other words, we get 13. So I'd like to tell you we could leave it like this, and the nice thing is there's no i's. No i's. This is way cool. But we want to write our answers, when you operate with complex numbers, like, you take complex number plus another complex number, or subtract a complex number, or you multiply two complex numbers, you should get a complex number in standard form result. So what we're going to do is we're going to recognize that this is a monomial divisor, monomial, which means there's only one term, which means everything on the top can be split up over this 13. So our final answer is going to be this, where we split everything up over the 13. We say negative 15 thirteenths plus 10 13ths, and we'll just throw our I over here, where our A part now is negative 15/13, and our B part is 10/13. Okay, cool. All right, so moving on to letter B, I said we do this one a little bit more quickly. What I really mean by this is we'll go ahead and put our 7 minus I. We'll rewrite this over here on the right. 7 minus I over 3 plus 4I. Okay. The fact is, to get rid of this in the basement, we know the technique is to multiply the top and the bottom times the conjugate of the denominator. So 3 plus 4I, its conjugate is 3 minus 4I. We're going to take the top times this as well. In terms of the quick way, what I mean by this is this. I recognize in the basement that our A is 3 and our B is 4. So what I'm really going to get is I'm going to get A squared plus B squared when I multiply these conjugates. And if that's the case, then I'm going to get 3 squared plus 4 squared, which is really just 9 plus 16, so I'm going to get 25. So to do this the quicker way is to find that first and just say, I know this is all over 25. So now, on the top, all we need to do is use our skills in multiplying two complex numbers, so we'll FOIL. So we get 7 times 3 is 21. 7 times a negative 4i is negative 28 of these i's. Negative I times a positive 3 is negative 3i. And then last but not least, we say negative I times a negative 4i is a positive 4i squared. Okay, so simplifying the top, let's go ahead and combine these like terms here. We get 21. A negative 28 minus 3 more would be negative 31 of those i's. And then last but not least, you know, this I squared is a negative 1. So we say plus 4 times negative 1. And this was all over 25. Furthermore, we say a positive 21 and a negative 4. 21 minus 4 is 17. So we say 17 minus 31i on top all over 25. And then our final answer is going to be where we split this up. We say 17/25. This is our A part of our complex answer. Minus 31/25 I. Okay? So this is our B part of our answer. Cool.